Hello, so I'm making this video in regards to the do now that was on Thursday, September 17th. And this problem here is to determine if these two equations are exact. So our first step here is to identify our P and our Q equations. So P here is whatever is attached to dx, so this would be arctan of y. And then our q is whatever's attached to y, so q in this case is x over 1 plus y squared. Our exactness test tells us that we need to take the partial derivative of p with respect to y, and then the partial derivative of q with respect to x, and see if those two partial derivatives are equivalent. If so, then our equation is exact. So here, partial p, partial y. This is taking the derivative with respect to y. So in this case here, arctan is of y. So we're going to derive this like normal. It won't really look much different. So this, in this case, would be 1 over 1 plus y squared. For q, again, this is the partial derivative of q with respect to x. So this one's going to be a little bit different because now we do have two variables going on here. We do have an x in our numerator and a y in our denominator. Since we are taking the derivative with respect to x, anywhere that I see y, I'm going to treat that like a constant. So in my brain, it helps me to pull out anything that has to do with y as a coefficient so that I can see that this is being treated like a constant. So I'm going to actually rewrite this, and let me downsize this a squish so that we have some room. So I'm going to rewrite this as 1 over 1 plus y squared, and this whole quantity times x. So in my brain, I see what I have in parentheses as just a constant, and everything there is going to remain the same. So when I take the derivative with respect to x, I'm just focusing on the x. What do I need to do to derive this? Well, this is just to the first power. So when I derive, I'm going to bring down that power of 1 and then put this as a 0 exponent. So we know anything to the 0 power is actually just going to be 1. So this whole quantity here just becomes 1. And then we're multiplying that by our coefficient. So this parenthesis here is going to stay the same, 1 plus y squared. And again, this is really just times 1, which we know would just simplify to 1 over 1 plus y squared. So again, our exactness test tells us that if our two partials are equivalent, then we are exact. So here, partial p and partial q are equivalent, so our final conclusion is that these two equations are in fact exact. Looking at the second equation here, we don't necessarily have our normal y's and x's. Here we have our s's and r's. So the order that this is written in, I'm going to treat anything that is attached to dr as p. So in this case, p is going to just be s, and then that means q is just r. So the important thing to note is that since we've said that p is attached to dr, we are going to take the derivative with respect to the other variable. So similar to the problem before, how we took partial p with respect to partial y, even though p was attached to dx. It's the opposite. So here we're going to take partial p, partial r, and then, or excuse me, partial s. I apologize, that was an error here. So again, since p is attached to dr, we are going to take the partial with respect to the opposite variable here. So ds would be our variable of interest. So since p is just s, when I take this derivative, we are simply just left with 1. And then partial q, partial r, here q is just r, so the derivative here would also be 1. So then our conclusion here is that our two equations are equal, and therefore our overall equation is exact. So hopefully this was helpful to refresh on exact equations, and specifically in number 1, how to take our partial derivatives.